66 million years ago, a 10-kilometer asteroid struck the shallow waters of the Yucatan Peninsula. This single event triggered a chain of environmental collapses that eliminated the non-avian dinosaurs and 75% of all species on Earth. The impact theory gained traction in the 1970s, when geologist Walter Alvarez and his father, Luis, began identifying specific crust anomalies pointing towards a cosmic origin for the extinction. Their evidence was a global geological boundary, a thin band of clay separating the Cretaceous and Paleogene periods. This layer contains concentrations of iridium up to 160 times higher than the background level. Iridium is rare in the Earth's crust, but common in asteroids. Despite the chemical evidence, many paleontologists remain skeptical due to the 3-meter problem. In fossil beds around the world, there was a consistent empty gap in the 3 meters of rock directly below that iridium-rich layer, making it impossible to see the transition in real time. Scientists had found the crater and the global chemical fallout, but the actual day of the impact remained a blank space in the geological record. They had the cause and the eventual effect, but were missing the immediate victims. That missing evidence was eventually located in the Hell Creek Formation of North Dakota. This site is significant because of its geography. 66 million years ago, it was a riverbank 3,000 kilometers away from the Yucatan impact site. At a specific site called Tanis, researchers found a dense, chaotic layer of fossils that defied the 3-meter problem. Here, the remains of the dead were entangled directly within the asteroid's impact debris itself. The site presented a mystery. It contained a mix of land plants, freshwater river fish, and marine creatures, all entombed together. Because Tanis was so far inland, it was unreachable by the massive ocean tsunamis that followed the strike. The way these animals were buried suggests a process that happened in an instant. The stacking of the sediment at Tanis doesn't represent thousands of years of slow accumulation. It captures the minutes and hours immediately following the asteroid's arrival. Tanis is a high-resolution ledger of the apocalypse's first hours, a place where the chaotic physics of the impact are preserved in the mud. Equivalent to a magnitude 10 or 11 earthquake, the Chicxulub impact sent primary seismic waves rippling through the crust at 5 kilometers per second. These waves reached North Dakota just 10 minutes after the asteroid hit the Yucatan. The ground began to vibrate with such intensity that it transformed the local environment into a liquid-like avalanche. This shaking triggered seiche waves, violent oscillations in the local river systems. Unlike a wave traveling across the open ocean, these were towering surges of water, between 10 and 100 meters high, triggered by the Earth itself vibrating beneath the riverbeds. These seiches arrived 18 hours before the actual ocean tsunami could have reached the area. This explains why the inland river systems were overwhelmed almost immediately, surging several miles inland and carrying marine debris with them. This rapid flooding solves the geographical paradox. Freshwater fish were crushed and entombed alongside marine creatures by a wall of water and sediment that set like concrete in minutes. As the ground shook, the atmosphere filled with debris. The impact vaporized the Earth's crust, ejecting trillions of tons of molten rock into space on ballistic trajectories. This molten material rapidly cooled as it fell through the atmosphere, forming glassy droplets called microtectites. Millions of them rained down over North Dakota. This glass rain fell at the exact moment the seiche waves were burying the Tanis riverbank. The timing was so precise, the droplets were trapped in the sediment layers as they formed. When researchers examined the fossilized fish, they found microtectites embedded in the gills of 50% of the specimens. These animals were still alive and breathing as the glass fell, inhaling the asteroid's debris while the water buried them. The presence of this glass in the gills locks the deaths of these animals to the immediate window of the impact. It proves they were killed by the direct physical violence of the event itself. The immediate kinetic slaughter was followed by a global climate shift. Vaporized sulfates from the seabed entered the upper atmosphere as aerosols, blocking the sun and triggering a sudden drop in global temperatures that devastated the food chain. As this global dust settled over the following months and years, it formed a final capping layer over the Tanis site. It permanently sealed the chaotic surges and the victims of that first hour beneath a layer of clay. This chart matches the ruthenium isotope ratios found in the Tanis clay to those of known carbonaceous asteroids. This chemical signature confirms that the material capping the fossils came directly from the impactor. Before Tanis, the extinction was often framed as a gradual process of climate change, but this site shows that for the animals on the ground, the end began as a sudden, violent surge of water and raining fire. Tanis provides a singular, high-definition view of the day the world changed, transforming a global, theoretical extinction into a minute-by-minute account of a specific riverbank in North Dakota.